A very good morning to all of you. So we are into SDWAN class number 5. So last time, as I remember, we have discussed about the lab and we were able to bring up VH3 and VH4 only on the internet service, right? So today, what will be the first task that we are going to do? First task will be, we will be understanding what is VPN segmentation. Again, I am repeating the topic, VPN segmentation, right? So I will directly jump into the practical, right? So it's not difficult to understand. So VPN segmentation means that under the same tunnel or under the same overlay tunnel, what we can do is we can send traffic for multiple VPNs, right? So to clear this thing out, let me just bring my snipping tool up. Right. So I think all of you remember this stuff that last time we were able to build overlay tunnel between VH3 and VH4, and we have seen that the networks behind VH3 were able to communicate with the networks behind VH4, and we have discussed that OMP will be the protocol that is responsible in SD-WAN to pass this control plane information, or you can say the routing information. So VH3 and VH4 are not communicating directly for any control plane information. They are communicating with whom? They are communicating with vSmart. So VH3 is advertising all its control plane, all its networks to whom? To vSmart. And vSmart is further advertising it to whom? To VH4. In the same way, VH4 is advertising the networks to whom? To vSmart, and vSmart is advertising to whom? To VH3. After that, if I dig into this, there were two type of routes we discussed, VPN routes, or we call them OMP routes, right? And after that, second type of routes were T-lock routes. So what were OMP routes? OMP routes was my LAN prefixes. LAN prefixes will always be binded with a T-lock, and T-lock routes will have the information related to the private IP, public IP, private port, public port, all of you remember, right? And here the T-lock will consist of three things, that was encapsulation, color, and what's the third thing? System IP, right? So I hope all of you remember this stuff that we have discussed in the last class, and I have shown you multiple times how you can look onto your VPN routes and on your T-lock routes. Now guys, the question is, if we have multiple VPNs, Rajesh, this is the problem with you or for everyone? Guys, can you hear me? Okay, it's breaking. Okay, you have to give me a minute. Let me know if it breaks again, right? Yeah. Okay. So here you can see a topology. In this topology, you can see how many VHs I have. I have two VHs, VH1 and VH2. How many service-side VPNs are connected on VH1? 3. VPN 5, VPN 10 and VPN 33. How many service-side VPNs are connected on VH2? VPN 5, VPN 10 and VPN 33. Now, all these VPNs, service-side VPNs, will be communicating inside the same VPN tunnel. Inside the same VPN tunnel. This particular thing is called VPN segmentation. Guys, I think all of you know what do you mean by segmentation. Segmentation means keeping the traffic separate. Segmentation means keeping the traffic separate. Right. When I'm saying we are keeping the traffic separate, what do you mean by that? It means that there will be some way to identify, right, there will be some way to identify that this particular traffic belongs to this particular VPN, but one VPN traffic will never be going to mix with other VPN traffic, right? So if you have to understand, you have to remember it like you can remember it like this, that VPN 5 can communicate with VPN 5, VPN 10 can communicate with VPN 10, VPN 33 can communicate with VPN 33, but inter VPN communication will not be possible. Clear? Now I think all of you understand that what do you mean by VPN segmentation, that by using the same overlay tunnel we can pass traffic related to multiple VPNs. So guys, what I will be doing right now is, if you remember, I told you that we have to do some basic configuration on the switch. Let me just go to the switch and let me show you. I have done that basic configuration. So my switch interfaces are already the member of the VLAN 223, right? Now I have configured that, right? Now I hope VH3 will have a OMP session. Control connections will be up. Show OMP peers. Right, so you can see VH3 has a OMP session with whom? With the vSmart. It means the routes which are advertised by VH4 to vSmart will be received by VH3. Show OMP routes. Yes, so if I want to check those routes in a better way, I will run the command show IP routes. Let me show you. Can you see we are receiving two OMP routes? What are these routes? Let me explain you. So you can see this is VH4. So we are receiving two networks. Let me go back to VH3. One network is 10.4.15.0. So this is the network I am running between VH4 and R15, right? Second is 15.15.15.15. It is a loopback existing on R15. So I am receiving both the networks via which protocol? OMP. Right? After that, what is the TLOC information? So you can see TLOC consists of three things: system IP, color, and encapsulation. It means VH3 knows if I want to reach this network, what will be the TLOC IP, what will be the system IP, 10.4.0.1. What color I have to use? What color I have to use? Public internet. What encapsulation I have to use? IPsec. Right? Now, what I am going to do here is, I am going to configure gig 0 by 3 here and gig 0 by 3 here, and I will make them member of VPN2, right? And I will be able to see the routes also, right? Let me do that real quick. VPN2 name, let's say this is your sales traffic, right? Which interface should be member of this? Gig 0 by 3, right? IP address will be 10.3.100. Let's keep it 100.3/24. No shutdown. That's it. Commit. Right? So now I have to do the same thing on VH4. Up to that time, no networks will be advertised. Let me go to VH4 real quick. Right? VPN2 name, any name you can give. It's not like you have to give the same name, right? I'm not giving any name right now. Interface G0 by 3. No shutdown. What network I want to run here? 10.4.100.4/24. Sorry. IP address 10.4.100.4/24. Right? Exit. Commit. Now guys, behind VH3, how many server-side VPNs are there? 2. Behind VH4, how many server-side VPNs are there? 2. Right? Now let's see from here, can I ping the other side or not? So if I want, I can configure R15 also, right? And if I want, I can configure R13 also. So let me do that real quick. Now guys, how many of you know the concept of VRF on a router, right? So I know that R13 already have a default route that is pointing towards whom? Towards this interface gig 0 by 2, and we know gig 0 by 2 interface on VH3 is member of VPN 1, right? So what I need to do? So guys, I will play here cleverly. How? Either I can configure E0 by 1 interface on R13 to be a member of VRF, or what I will do here is interface E0 by 1 no shut IP address is 10.3.100.13, right? And I will define a static route that if you want to reach which network, 10.4.100.0, please go to which interface of VH3? Gig 0 by 3. So what is the IP? 10.3.100.3, right? And let me try to show you the ping also to this next hop. So we are able to ping. Let me write the configuration, right? So let's come to R15 also. Interface is 0 by 2. No shut IP address 10.4.100.15, right? And I will define a static route here that if you want to go to 10.3.100.0, please go to whom? Go to 10.4.100.4, right? And who is this 100.4? Gig 0 by 3 on VH4, right? Clear? Either I can configure a VRF here on R13 and 15 to segregate the traffic, or I can do it by simple routing, right? So now if I go to VH3 and if I check show IP route, let me show you, sorry, show IP route. We can see we are receiving 10.4.100.0 again as a OMP network, right? And you can see the same T-lock is there because I told you the overlay network will remain same. The overlay network will remain same. So all the prefixes, let me show you, show IP route, VPN1, either I am getting in VPN1, right? Or I am getting in VPN2. Show IP route VPN2, right? VPN2. The T-lock is same, right? So the overlay network will remain same. It's not like that for VPN1 there will be a separate overlay, for VPN2 there will be a separate overlay, right? The overlay network, the tunnel between VH3 and VH4 is still same, right? And how the traffic is segregated? The traffic is segregated. In the traffic, we put a tag, we add a tag for which VPN, VPN 5, VPN 10, VPN 33, right? So this is how we do it, right? Let me show you one more thing. Can you see here? So here you can see this is the basically VPN tag that is present in my traffic, right? So this VPN tag is always encrypted. You cannot see it in the real-time traffic, right? This is behind whom? This is behind ESP. So above your data, there will be a VPN tag. So the other end will automatically know that this particular traffic belongs to this particular service side VPN, right? But what I am trying to tell you here, the overlay tunnel between two VPN, two VHs will remain same. There will be a single overlay tunnel, right? So let's go back to the topology and let's try to see. Go back to VH3, show IPsec outbound connections. So how many IPsec connections are existing between VH3 and VH4? Only one, right? Show BFD sessions. How many BFD sessions are existing between VH3 and VH4? Only one, right? So there is a single tunnel between VH3 and VH4. That tunnel is passing traffic for VPN2 also, VPN1 also, and how it is differentiated with the help of tag that is present in my data traffic. Guys, anyone has any problem, feel free to ask. Anyone has any issue understanding this, feel free to ask, please. Right? So this is the basic concept, right? Now, what is the logic behind these different VPNs, right? So I'm giving you an idea what is the logic. So guys, we know in an enterprise there are multiple types of traffic, and what we want is we want every traffic should be separated from the other traffic. And apart from this, I'm giving you some idea, right? What is that idea? Let's say I have two types of traffic, right? One is my marketing traffic, right? And other is my, let's say, software development team traffic, right? So what is my requirement? Let's say these are my three sites, 1, 2 and 3. Fine. I know marketing people are present at every site. So these are marketing people, right? Marketing. M marketing, M marketing, M marketing, right? So these are marketing people. What I want these people to communicate with each other without any dependency or in a full mesh way. So I'm configuring them to be a member of VPN1. So this, let's say VH1, 2, 3. So the networks behind VH1 will be able to communicate with VH2 directly, VH1 with VH3 directly, VH2 with VH3 directly. So what I call this full mesh. So what I want is for marketing traffic, there should be a full mesh topology. So networks behind any of the VH, if they are a member of marketing, they should be able to communicate directly with the networks behind any of the VH, right? There should be no dependency. But this traffic, software development traffic, right? So what I'm going to do? Let's say this is a critical traffic and I want this traffic to pass through a firewall. Right? So let me tell you in the same design. So we have second sort of traffic, that is my software development traffic, right? Software development, right? And we have a firewall for software development here on behind VH1. This is a firewall. And what we want, if any of the software development site want to communicate with the other site, it should pass the traffic to this through this firewall, right? So what we want software development traffic to be forwarded to which site? To VH1 site, right? So this is a hub and spoke kind of environment. So we will keep it under VPN2, and for VPN2, how we will set up the tunnels, that VH2 will always send the traffic to whom? To VH1, and it will pass through the firewall and then it will go to VH3, right? So what does this environment? Hub and spoke. So for different VPNs, we can have a different sort of communication. So this is again the magic provided by SDWAN. Right? Fine. So let me just give you one more pictorial representation of the same. Right, you can see here For like here, for VPN 1, I have a full mesh topology. For VPN 2, we have a hub and spoke. For VPN 3, I only want these sites to communicate. I don't want this site to communicate with this site, right? And for VPN 4, I want to have a point-to-point connectivity. Means I only want these two sites to communicate directly, these two sites to communicate directly, these two sites to communicate directly, and these two sites to communicate directly. I don't want this communication. No, no, no. I can set it up, right? So this particular thing is called VPN segmentation, right? So here also in my topology, what I am doing, I have networks behind V edges which are part of different VPNs, and I am making communication possible between them. But you have to keep one thing in mind, that the overlay network will always remain same. Now let me go to the R13 and let me try to ping 10.4.100.15, right? And I am able to ping. I am able to reach without any problem. Trace route, let me trace route the site. Numeric. Now it is going to 10.303. Who is this? Gig 0 by 3 of VH3. Gig 0 by 3 of VH3 is part of which VPN? It is part of VPN 2, right? And now the traffic is passing through the SDWAN fabric. So I told you, what do you mean by SDWAN fabric? My connected components to the fabric will see the whole fabric as a single device, right? So at this point traffic is entering the fabric, and at this point traffic is exiting the fabric, right? So guys, after that traffic is reaching to the final destination. So if you have any problem understanding this, let me know. Can you repeat your question? Yes, please. Right. So, okay. Show OMP. I explained it last time, no problem. Show OMP TLOCKS detail, right? I want to see it in a tabular form. Okay. Actually, my font size is very big, that's why it is creating a problem. Let me remove the tab keyword, right? So let me show you in just a minute. So here you can see TLOCK entry for 10.4.0.1. This is the system IP, this is the public IP, and this is the encapsulation. Sorry, this is the color and this is the encapsulation, right? So to reach this particular TLOCK, here we have the information that this is the public IP I have to use, and these are the ports, right? So to answer your question, so that you can also remember it, it is very simple to remember how the underlay information is provided in the TLOCKS, right? The underlay information means the actual physical interface IPs are provided in the TLOCK, right? So the next topic will be, I will be bringing up the MPLS transport, right, in the fabric. So guys, you have to concentrate first of all how I'm bringing it up, right? So first of all, let me do the configuration on the MPLS router. I have not enabled it till now. No enable. So this is my MPLS. Right. So I will not enable all the interfaces for now. I will only enable the interfaces which are connected to DC switch, VH3, VH4, right? So let's start interface E0 by 3. No shutdown, IP address 172.31.13 dot let's say 1, right? interface is 0 by 0. Okay, it's 0, it's 0. No shut, IP address 172.31.20.1, right? Interface E1 by 0. This is the interface connected to VH4, right? IP address 172.31. After that 14.1, right? After that router BGP. What AS number you want me to use? Let me use here 100, right? So this MPLS cloud is running BGP AS 100, right? Neighbor 172.31.14.2, right? Remote AS. So I will run here AS number 65004, here AS number 65003, and here AS number 65100. So after 65 I will add the site ID, right? So the site ID is 4, so 65004, the site ID is 3, 65003, the site ID is 100, so 65100. So 14 is 65004, right? Neighbor 172.31.13.2, remote AS 65003. Neighbor 172.31.20.2, remote AS 65100. Clear, guys? So I am able to form neighborship on this MPLS router with VH3, with DC switch, and with VH4, right? So this is no rocket science. Just try to remember your concepts that you know about BGP, right? So let me now go to DC switch, right? This is my DC switch. Router BGP 65100, right? Neighbor 172.31.20.1, remote AS 100. Any problem, guys? No. Neighborship is up. Now try to understand what I'm going to do. Let me just first of all, so guys, I'm only taking snip of this particular section because I'm not touching the other part of the network. Let me just go down, right? So this is which transport internet, this is which transport MPLS, right? So my cloud is connected to MPLS. So what I will be doing, I will be advertising this subnet over MPLS to whom? To AS100, so that VH3 will also receive the subnet and VH4 will also receive the subnet. Through which protocol? BGP. So why it is required for VH3 and VH4 to learn this subnet by BGP? Let's say if this particular internet link goes down, so VH3 will not be able to form any control connection with the controllers, right? So that's why for a redundancy purpose, what we are going to do, we are going to build two transports, right? Just for which purpose? Redundancy purpose, right? So I will be showing you the control connections once again when I will bring up this transport, right? So just give me some time. Let's go back to the topology, right? Let's go back to my DC switch, and here let me advertise the network 223.1.1.0 mask, right? So we are good. So I hope MPLS router will be receiving the subnet. Let me show you. Show IP BGP. We are receiving the subnet, right? Without any problem. Now let's go back to VH3. Now guys, first of all, let's have some outputs, right? First of all, show IP route. This is the current routing table I have, right? Let me just open a notepad. Okay, I will not start with show IP route. Let me start with show control connections. Right, so let me just try to make it a bit more big. Guys, shall I decrease the size of putty? Guys, let me know please. Okay, no problem. This is the first output. Okay, okay, we have it here. Fine. After that, show OMP PHs. So these outputs are with single transport, right? Clear, guys? After that, show IP route. This is the routing table. Right? After that, show BFD sessions. After that, show IPsec outbound connections. Right. So let me just copy paste this output. So this all output is present with how many transport? With a single transport. Now guys, first of all, what I'm going to do, I'm going to configure gig 0 by 1 interface on VH3. Second thing is I will turn on BGP on VH3. After that, VH3 will have two transports and I will show you the outputs, right? How the control connections are built when we have two transports in place, right? So the first part is very simple. Go to the config mode, which VPN? VPN 0. Which interface? Interface G0 by 1. What is the IP address, guys? IP address is 172.31.13.2/24. No shutdown. Tunnel interface, right? Encapsulation, IPsec, right? After that, color, MPLS. So the difference here is on gig 0 by 0 interface, there was a public IP. Then there was a tunnel interface, encapsulation was same, but color was public internet. Here the color is MPLS, right? So every WAN transport will have a different color. Clear? And at last, allow service all, so that all the services will be enabled on this tunnel. And at last, let me do a no shutdown, exit, exit, commit. So now my interface is configured, right? So if I try to ping 172.31.13.1, I am able to ping. So this is the IP address on the MPLS device, right? Now let me show you how you will configure the BGP. Conf T VPN 0. Now many people get confused when configuring BGP, as they have experience of configuring BGP on the iOS router. Show run pipe section router BGP, right? So guys, just concentrate here. Concentrate here. Let me just do one thing for you. I don't know you know about it or not, but let me do it. Command was just a minute. Just a minute, guys. I want to show you one thing. Default BGP. Okay, I think command is BGP default. BGP. Okay. Show run all pipe section BGP. Here is the command. Okay. So what I'm going to do now is I'm running this command, and what difference this command will make, look here. Now guys, you can see my configuration is changed to address family mode. So what do you mean by address family? If someone does not know, so BGP support multiple address families, like BGP support IPv4 also, IPv6 also. Okay, let me discuss it from a noob perspective, like if you don't know anything, right? So guys, tell me one thing. Let's say you want to configure EIGRP, right? For IPv4 and IPv6, how many EIGRP processes you will run on the router? 2. If you want to configure OSPF for IPv4 and IPv6, right? How many OSPF processes you will configure on the router? 2. But in case of BGP, you don't have to do the same. Why? Because BGP supports address families, right? Under a single BGP process, I can bring up IPv4, IPv6, multicast, VPN v4. So multiple address families are there present in BGP, which are helping us in, right, forming the neighborship. So if I want to run multiple address families also under BGP, it is possible. Yes, it is possible. So by default, the address family IPv4 is enabled, right? So whenever you write a neighbor command, router directly form a neighborship. So I turn off that feature. So now whenever you define a neighbor command, what you have to do is you have to go under the address family and you have to activate the neighbor. It means now the neighborship is broken into 2 parts. What is the first part? The first part is I have to define the neighbor. What is the second part? I have to activate the neighbor. So now there are 2 things. Definition. First is we have to define the neighbor. Second, we have to activate the neighbor. Right? Again, I am repeating. First is we have to define the neighbor. Second thing is we have to activate the neighbor. Right? So when I am saying defining the neighbor means neighbor command. When I am saying activating the neighbor, go to address family and activate. Right? So now if you are familiar with this sort of configuration, you will have no problem understanding the VH configuration. Let me just show you. Okay, let me just make it a bit. So see on this side also how we are configuring it on the iOS router, and see it here also. VPN 0, which routing protocol I want to configure? Router, question mark, BGP, question mark, AS number 65003, because we are on VH3, right? Now we are where? We are in router BGP AS configuration mode, right? Here, do a question mark. How many commands are available? Address family, right? Neighbor. So let's define the neighbor. Clear? Neighbor. Which neighbor? 172.31.13.1. Enter. Enter. So now I am in neighbor configuration mode. Here I was writing directly that this neighbor belongs to this AS, but on VH it will not be like this. First of all, I will go in the AS number configuration mode. From AS number I will go to neighbor configuration mode, and here I will write the AS number. Remote AS is 100, right? Clear? Any problem in understanding this? No. And after that, if I do a question mark, I cannot do anything here. Exit, exit, commit. So commit is complete. It means this MPLS router should have built neighborship with BH3. Okay, it is saying there is some problem with the AS number. What is the problem? Let us verify. Show run pipe section BGP. Okay, guys, can you? Yeah, I advertised it wrong here. So let me correct. Router BGP 100, right? No. Six 5003, right? I think it is correct now. MPLS router should build neighborship. Show run VPN 0. Router BGP, right? So you can see the configuration here. Show IP BGP summary. So neighborship is idle. What's the problem? Let me check once again. Section BGP. Okay. I have changed the AS. Now I have to activate the neighborship also. Right. So I will go to the BGP configuration mode, address family mode, neighbor, and what I will do? Activate, right? So once I activate my neighborship will come up. It is up, right? So if you see, show IP BGP summary. Sorry guys, show IP BGP summary. Fine. So with 13.2 we have a neighborship. Now guys, the next question is, we are running here MPLS. So what we want? We want VH4 to know about this network, the MPLS network, because this is the WAN interface on VH3. So there are two ways to achieve that. First is you can advertise this network on MPLS router, right? And it will advertise it to VH4. Or you can do is you can advertise it on VH3. So I will show you how to advertise a network on the VH3, right? Because you already know how to do it on the iOS devices, right? So again, VPN 0, router, you can run it like this also, router, which BGP 65003, address family IPv4 unicast. And here you can, what you can do is, here you can advertise your network. What is your network? 172.31.13.0/24. So what we are doing is, we are advertising the directly connected network, the WAN network on VH3 in BGP, so that anyone who is connected to the MPLS transport should be knowing about this network, right? Clear guys? Okay, let me do a commit also. Commit is completed. So let me show you how you will check the BGP neighborship here. Show BGP neighbor, right? BGP neighbor is whom? 172.13.1. What is the AS number? 100, right? State is established, right? Show IP route. Let me just show you the BGP networks which we are receiving from the MPLS cloud. Can you see we are receiving 223.1.1.0 via which protocol? BGP. E means eBGP, right? And what is the next hop? 172.31.13.1. It means now my VH3 has the both transport build, right? Both transport build means, again I am repeating, VH3 is connected to the WAN via how many transport? Two transports, right? It means VH3 will try to form control communication across how many transport? Two transports, right? Now let's run the same commands. First command was show control connections. show control connections. Can we see the increase in number of control connections? Let's match it. Look here, guys. Earlier, there was one connection to vSmart, one connection to vBond, right? And one connection to vManage. By default, there were only one connections, right? I'm talking about the DTLS, control connections. Now, if you see, VH3 is having two connections to whom? To vSmart, right? Two connections to whom? To vBond, right? Right? And only one connections to whom? vManage. Now the question is, Piyush, why it is forming only one connection to vManage? There is a particular reason, right? What is the reason? I will explain you, but you can see VH is building one connection via each transport with whom? With vBond and vSmart. I am talking about which connections here? DTLS, right? Clear, guys? Now only one connection with vManage. So let's understand why this is happening. So guys, if we talk about redundancy, let's say this is your controller environment. So in your controller environment, you will always, you can have multiple vSmarts, right? You can have multiple vBonds, right? But when I'm talking about vManage will always be a cluster. Cluster means you will integrate multiple vManages into a single vManage, right? So let's say this is your vManage 1, vManage 2, vManage 3, right? Now for the outside world, it is a single vManage, but actually physically how many vManages are there? 3. So every time a VH will come up, it will only form a single connection with whom? With vManage, right? It will never form multiple connections with vManage across multiple transports, right? Always a single connection. Always. You will never see multiple connections to vManage, right? Never. Never means never, right? So it does not matter how many transports you have, you will always see a single connections to your vManage, because vManage is always a cluster. Now let's compare the next command. Next command was show OMP peers. Show OMP peers. Oh God, what is happening? Still one OMP session on two transports. Yes guys, this is true. So OMP session will remain one between VH and vSmart. It does not matter how many transports are there. For every transport there will be a DTLS session, right? There will be a DTLS session. So if I have to explain you the design, so if you have knowledge about BGP, let's say this is R1, here is the loopback 1.1.1.1. This is dual links. This is R2, here you have a loopback 2.2.2.2. How many BGP neighborship you will build? I will build a single BGP neighborship on the basis of loopback, right? But how many paths will be there? 2 paths, right? Right? In the same way, if I talk about the DTLS connections, so DTLS connections will be there per transport. So 2 DTLS connections will be there. But how many OMP sessions will be there? Only 1. Clear? So this is what you have to remember always, right? If I will move on and I have to check the routing table, now you will see the difference. Show IP routes. Now let me show you. The difference. We are not learning any network via. Okay, routing table we will compare once we will enable MPLS on VH4, right? Only then it will make sense, right? So let's go to VH4. Now the configuration is pretty simple. So guys, I will not wait this time. So AS number will be 65004. My network will be 172.31.14.0. Neighbor will be 14.1, right? AS number 100, everything good. Copy, paste. You can see I've copy pasted the configuration, right? So let me do one thing real quick. BGP config on VH4. Here we go, it's for you, right? So when you want the configuration, you can see it from here. Let me just save this file also. This is the output diff with 1 versus 2 transports, right? And here you will also see we are bringing up the MPLS cloud, bringing up MPLS cloud. Look here. Now let's go to VH3. Now let's see the routing. Okay, let's go to VH4 once. I have not committed the configuration, right? So sometime I also make mistakes. Right, once I commit the configuration, let me check show OMP sessions. Sorry, show IP route. Okay, we cannot see any routes from the MPLS logs. Show OMP peers. Okay, there should be now. Okay, show run VPN 0. Let me see if I have any configuration. Okay, this is the problem. Okay, let me do it. Let me remove this configuration, guys. So this is the previous configuration we have here in place. VPN 0. Tunnel interface, no group 100. Commit. Show run VPN 0 interface. Okay, here also we have that interface. Let's go here. VPN 0 interface G0 by 0. Tunnel interface, no group 100. Commit, right? Now see the routing table. Let me show you. Let's wait for some time, because I am expecting VH4 to receive all the networks via both the transport, right? Show BGP neighbor. Okay, the state is active, still active. What's the problem? Let's go to, okay, let's go to the MPLS device once. Show IP BGP summary. What's the problem? 14.2, that is correct. Okay. Show run VPN 0 interface G0/1. Oh guys, I made a big mistake. Let me show you what is that mistake. Show run VPN 0, right? So mistake like this also you will also make when doing the configuration. I've configured, first of all, what? I have configured BGP, but I forget to configure G0/1 interface on VH4, right? So let me configure it. So interface will be 14.2 color MPLS VPN 0. Let me do that real quick. Now commit, right? I forget to configure the interface. I was configuring BGP directly, right? That is correct now. Okay, still there is a problem. Let me see what is the issue. 14.0 neighbor 14.1. That is correct. Show run pipe section BGP. What is the issue? 14.2. What is the IP address we have assigned? 14.2. That is fine. Let's try to ping 14.2. Let's try to ping 14.1. Okay, there is an issue. What is the problem, man? Show IP interface brief. Okay, 14.1 IP is also correct. Let me check the topology. So this is VH4 E1/0. Can you see E1/0? Okay. Just a minute. Okay, let me just cross check once. No issues. VH4. Show run VPN 0 interface G0/1. It is okay. Man, can anyone tell me what is the problem here from this configuration? Yes, it's down. Very good. VPN 0 interface G0/1. No shutdown. Exit, commit. Right. So show BGP neighbor. So neighborship is established. Now we are good. Now fine. So control connections we were already clear from VH3. Now we have to check the routing table. Now see the difference. Yes, this is what I was expecting from the output. Now see the difference. The point is, this is the output we have when we have only a single transport. So all the routes were learned only from one transport, right? One T-lock. What was that T-lock? 10401 public internet IPsec. Now every OMP network is learned via how many T-locks? 2 T-locks. MPLS also and public internet also. MPLS also and public internet also, right? So guys, first question. So whenever I interview people for SDWAN, I ask them, right, what is the difference you can see here between these two T-locks? So they are like, these are same. No, they are not same. T-lock is represented by how many things? 3 things. System IP, color, encapsulation, right? Now, if you see color is different for both the T-locks, it means there should be some difference. What is the difference? Let me show you. Let's go to one of the VH. You can go to VH3, VH4, wherever you want to go. Show OMP T-locks, right? Now see, let me show you. And not the self-generated T-locks, but the remote T-locks I'm talking about here, right? I'm checking 10401 MPLS IPsec. See the private and public IPs here, right? These are my MPLS IPs, right? Clear? And for 10401 public internet, these are my internet IPs. Clear? So the underlay IPs are different in both the T-locks. Clear? So now I will receive routes by both the transport, not just via single transport. You can see here the difference. After that, if I talk about the BFD sessions, show BFD sessions. Show BFD sessions. So how many BFD sessions are there? Now guys, this is magic. What I'm calling it? Magic. How many BFD sessions are there? 4. From 1 to 4. Piyush, what is this going on? Okay, let's see. 1 to 4. Okay, I'm not able to copy the whole output, but I want to. I want to copy the whole output. Let me remove it. Now guys, listen to me carefully. We have already discussed this thing. I am just showing you. How many BFD connections were there? 1. Now how many are there? 4. How 4 first of all? Right? How 4 first of all? So let's go back to, let me just open up class 4 notes. Right. See here guys. So by default, if I have two transport, this particular transport T1 will try to form a tunnel with T2, T3 also and T4 also. Right? T2 will try to form with T3 also and T4 also. So in the end, how many IPsec tunnels will be there by default? 4. Again I am saying 4. It means what is going on here, if I look from my topology perspective, let's come here. Right, so step number 1, VH3 is trying to form first tunnel over internet transport to the internet transport of VH4. That is correct. But side by side, VH1 is also trying to form a tunnel from internet transport to the MPLS transport of VH4. Second tunnel. In the same way, VH4 is also trying to form one from internet connection to where? To the internet connection that we have already discussed, and second from internet connection to where? To the MPLS, and from MPLS to where? To the internet. So how many total tunnels are there? They are trying to form 4, right? But see the magic here. The magic is only 2 tunnels are up. Which tunnels are up? MPLS to MPLS, public internet to public internet. The tunnel which is sourcing from the MPLS T-lock and going to public internet is down. Right? The tunnel which is sourcing from public internet and going to MPLS is also down. Why they are down? Because there is no reachability between MPLS and public internet. There is no reachability between MPLS and public internet. Clear guys? Are you clear with this thing? Guys, any problem? So this is the by default behavior of SD-WAN fabric, that it will try to form tunnel from every available transport to every available remote transport. Clear? But only which tunnels will come up? Which are member of same transports or same T-locks, right? Or same color, right? So only 2 tunnels are up. But how many total tunnels are there? 4. In the same way, if I talk about show IPsec outbound connections, how many connections are there by default? 4 connections, right? Why 4 connections? Again, I told you there are how many BFD sessions? 4. So how many overlay tunnels are there? 4. If you remember, I told you for every overlay tunnel there will be a BFD session. So 4 overlay tunnels, 4 BFD sessions. But how many BFD sessions are actually up to? So if you want that only device will try to form an overlay tunnel in the same color, you can do it. How? Very easy. VPN 0, right? VPN 0, interface G0 by 0, right? Okay, let's go to interface G0 by 1, tunnel interface, color, MPLS, which option? Restrict option. Commit. VH4, let's go to VH3 also. VPN 0, interface G0 by 1, tunnel interface, color, MPLS, restrict. Commit. Now what is going to happen? Let us see. How many BFD sessions are there? Only 2. Both are up. Right? Show IPsec outbound connections. Right? So what I will do is, I'll just copy paste this output, paste it in the notepad, and write here, once we apply the restrict option, this will be the output. And how to apply the restrict option? It is also simple. Show run VPN 0, right? Just go to this interface tunnel, and these are the commands that I need to run, right? Remove IP address. So these are the commands that are required. Not encapsulation, only color, MPLS, restrict. And guys, let me tell you one thing very clearly. I also sometimes got confused with the stuff because I'm not dealing it with on day-to-day basis, right? So these are the commands. Just commit the configuration, and after that you can see the difference. Fine. Now what is going to happen? Only same transports are going to communicate. Clear, guys? Any problem in understanding this part? If yes, please let me know. Okay. So Samir, I was not checking the chat at that time, right? So this is how the things are happening here. Now what I need to do is, I need to show you some more things, right? So let's go to vmanage admin, right? So many times people ask me, Piyush, okay, now we have 2 paths. Just show us the notepad file, okay? Now we have 2 paths. Let me open up a routing table. Let's say now VH3 knows that to reach, okay, or VH4 knows to reach 13.13.13.13, I have 2 T-locks. So which T-locks are used? Okay, so let's see, check it. What is the problem? Resend. Okay, sometimes this thing happens and I resolve it by writing here 8443. I'm not saying always, sometimes if this happens, you can resolve it like this, right? Actually 8443 is the port number of the vmanage cluster. So whenever we form vmanage cluster, we does not access it on 443, we always access it on 8443, right? So let's come to monitoring network, right? Which VH? Go to any of the VH, man, right? So go to real time. Here we can check the routing table if you want to check again. So OMP received routes. Do not filter anything, just show me the output. So guys, you can see we are receiving 13, 13, 13, 13, right? And via MPLS also and via public internet also. This is the encapsulation. This is the system IP, and this is how the networks are advertised on the. Okay, so these are my local networks. Let's concentrate here on 50. So these are the remote networks, right? I'm getting from up here. Okay, these are installed. This is the system IP. This is color, IPsec. I explained you last time the origin, right? Origin protocol. Remember, where we will get to know how these routes were injected into OMP, right? Now, if I go to troubleshooting and if I go to let's go to simulate flows, right? So what I'm trying to show you now, that if I try to send any traffic from VH3 to a network across VH4, which path it will use, right? Because now I have how many paths in routing table? Look here. If we check that notepad output to reach, okay, so this is the output from VH4, right? So we are on VH3, so I think you can think vice versa, fine. So to reach this 13 network, I have 2 entries, right? In a similar way, I'm on VH3, so if I try to send traffic from VPN1 from my side, right? This should be the source IP. What is the destination IP? 15.15.15.15, right? So if someone is not clear, look here once again, that from VH3 I'm trying to send traffic across VH4 connected device, that is R15, and I will click on simulate. Now I am able to see that by default both the transports are used. By default, both the transports are used. So R3 is sending some of the traffic over which transport public internet and other traffic over which transport MPLS. It's not like that one transport is preferred over other transport. So it is performing load balancing. Clear guys? Any question? Feel free to ask. There should not be any. No, see, Sameer, see, try to understand what I'm saying. This is the by default behavior, right? Now, if you want that your MPLS transport should always be prioritized, you can do that, right? Or should always be preferred. I agree with you that MPLS will always have a least latency as compared to internet, right? Because on MPLS, traffic is always prioritized by QoS. But in case of internet, traffic is always forwarded on best effort basis, right? So MPLS path is always better than internet if I'm talking about site-to-site communication. But here I'm telling you what is the by default behavior, right? How one site is reaching to the other site. Okay, so when I am simulating the flow, it is showing me that whenever you try to reach this destination, right, it will use this path, right? But for a single flow, single path will be used. What do you mean by single flow? How many of you know about Ceph? Let's say this is one source, this is source 2, this is your one router. Just a minute. Fine. See, so this is your second device, right? And there are two paths. I'm telling you the meaning of flow-based load balancing. What is happening here in SD-WAN? Source 1, source 2, destination 1, destination 2, right? So let's say this is path 1, this is path 2. So let's say source 1 is sending traffic to destination 1. So when traffic will receive the device will select one of the path. So let's say it has selected the path P1. So all the traffic will pass through the path P1, right? And it will receive D1. Now, let's say source 2 is sending the traffic to whom? To destination 2. So this time, again traffic will be received by the device. Now device will select. There is an algorithm device is running to calculate the path. So let's say the path selected is P2. So all the traffic from S2 to D2 will be forwarded from which path? P2. This is called flow-based load balancing. What I am calling it? Flow-based load balancing. Right? Clear? So let's say now source 1 is communicating with destination 2. So this time one of the path will be selected and it will always be used. Now let's say source 2 is communicating with destination 1. Again, one of the path will be selected and it will be used. So by this way we will be able to use both the paths. Any problem? Feel free to ask. Right? So load. Okay, so trace route is a different kind of utility. When we talk about traffic, traffic is a different kind of utility, right? Here I am talking about the actual data plane traffic, right? But trace route is a different sort of utility that will show you all the available paths, right? Yes. So now we have done the practical related to the restrict keyword, right? Now after that I will not dig too much into it. Yes, I will be showing you one of the practical how to do some route manipulation in the future. But I want to discuss more on this point now, right? What is that point? OMP best path selection. How OMP selects the best path, right? How OMP selects the best path, right? So guys, first thing, so let's make this a good discussion, right? What do you mean by best path? Right. Okay, anyone want to answer? Okay, so first thing is, whenever I am saying I want a best path, it means I have more than one path, right? I have more than one path. Let's say there is a router R1, here you have R2, here you have R3, here you have a 100 MB link, and here you have a 1G link, right? And they both are connected to a destination. So this is a server, right? This is your server, one of the server. Let me connect it like this, right? So this is R1, R2, R3. This is your 1G link, sorry, 100 MB link, and this is your 1G link. So now R1 has two paths to reach which device? This server. Or let's say here we have a LAN. So this LAN A has how many paths to reach S? Two paths. One is via this 100 MB link, one is via this 1G link. So according to you, which path will be preferred? We will always prefer this path, right? So when we have more than one path, device need to select the best path, right? But what we have seen is the IGPs that we have studied, right? IGP means the OSPF, EIGRP, RIP can have equal cost load balancing, right? But what we have studied in BGP, by default maximum paths are 1. So if you have multiple paths to a destination also, it will always select one path as the best, right? But in case of OSPF, EIGRP, RIP, by default maximum path value is 16 or 8 or something like that, 4 depending upon the operating system. What is my point here? That if you have multiple paths available in OMP, in which protocol? OMP, right? How many paths will be the best path, right? How many paths will be the best path, right? So by default in OMP, keep this thing in mind that first of all, I'm clearing one thing, that VH is forming, VH or CH is forming OMP neighborship not with the other VH. With whom? With vSmart, right? And vSmart is forwarding it to via OMP session to another VH, right? So let me just mark them VH1 or 2 so that you will not be confused. So by default vSmart is only allowed to advertise 4 paths for a given prefix, right? For a given prefix. If you want to change this behavior, there are some commands called send path limit, right? You can change this limit from 1 to 16. It depends on you, right? How many best paths you want to advertise, right? Fine. Now let's say you have 4 paths, right? How many paths are there? 4 paths, right? Path 1, path 2, path 3, path 4, right? And you are using this command send path limit as 2, right? As 2. 2 means how many paths you will advertise. How many paths this vSmart will advertise? Only 2. Maximum how many paths? 2 paths, right? Again, you can run a command send backup path, right? Send backup path so that it will advertise this 2 plus these 2. So these are your active paths and these are your backup paths. So all the paths which are advertised by your vSmart to the other VHs are called active paths, and the paths which will remain only on the vSmart are called backup paths. So you can use this command send backup path to advertise the paths which are the backup one, right? Clear? This thing is clear? Let me see if I can run this command on my vSmart. Right. We never deploy or change these things in real-time scenarios because 4 paths are more than enough, right? Sorry, VPN 0. Okay, let me do this like this. Show run all. Sorry, show run. Let me just maximize it. Okay, someone is trying to ping me. One minute, guys. I think I need to go under OMP. vSmart. Send path limit. Okay, what limit I set? Guys, check, please check. What limit I set? 1. It means how many paths for a prefix will be advertised by the vSmart now? 1. Let's go back to VH. Yes. Guys, how many of you are with me on this? That VH4 is only receiving a single prefix from vSmart for 13.13.13.13, and that is also via whom? MPLS, not via internet. Guys, any doubt till this point? Please tell me if you have a doubt, because now I will be jumping into the topic that how vSmart is taking the decision that the MPLS path I have to advertise. I don't have to advertise the public internet path. Guys, please, this is a request from my side. If there is any problem, please discuss. Because let me be very honest here. Once I start with the templates, right? Once I start with the templates, things will be like boom. Because I will not lift with any concept. Concept is already I am discussing here. I will just show you how you will be doing configuration on VHs in real-time scenarios. Okay, Samir, there is no color preference, right? Have we set any preference? No. So what we are seeing here, I am explaining it for the last time. This VH3 is advertising VPN1 routes by how many T-locks? T-lock internet and T-lock MPLS. To whom? To vSmart. Now vSmart is configured with send path limit. What value? 1. And it is advertising only the MPLS path over to whom? To the other VH. Right? Now we will understand how best path selection works in case of OMP. Right? Guys, feel free to ask if you have a doubt. Again, I am saying, right? So this is for you, not for me. Clear? If you check here, show run now, I think you will see. Yes, you can see send path limit 1. Right? Show OMP routes. I don't know why it is not showing. Okay, here it is showing me in tabular form and I'm liking it. Okay, for okay, let's choose a prefix. Fine, let's choose 13.13.13.13. Look here, concentrate, right? 13.13.13.13 is received from 10301, right? And it is installed in the routing, it is installed in the OMP table. These are the TLOC IPs. Now the question is, why this vSmart is advertising the MPLS prefix, not the internet prefix, right? So I'm showing you what is the criteria for what I say for selecting the best path, right? For electing the best path. Okay, so this is my prefix. Let me just copy paste it. गीत गाता हूँ गुनगुनाता हूँ। Look here. This is the best path selection criteria. It goes like this. First of all, it goes like this. Okay. First thing that a vSmart will check is if the route is active or not. Route is active. So both the routes are active. That's why they are advertised, right? Next thing a vSmart will check is we are able to resolve the next hop TLOC or not. We are able to resolve, right? After that, it will check the locally sourced route over vSmart route. So this particular point is only true for VH, not for vSmart, because vSmart will not source any route, right? Edge will only source the route, right? After that, prefer OMP route with the lowest AD. Things will start from here. So guys, have we changed any AD? First of all, the question is, what is AD value for OMP? AD for OMP is 250, right? Fine. So we have not changed any AD. So on my vSmart, AD value is same, right? After that, route preference. So the route with highest route preference will win. We have not manipulated any route preference. Fine. After that, TLOC preference. The route with the highest TLOC preference will win. We have not changed any TLOC preference, right? Clear? After that, origin. Router will advertise the routes with best origin, right? So origin is also same in our case. If I talk about 13.13.13.13, this is the network which is advertised as static on VH3. After that, prefer route with lowest origin system IP. So this route is originated by whom? With VH3. And for both the TLOCs, my system IP is also same, right? Last is prefer the route with lowest TLOC private address. Now let's compare it. Show OMP TLOCs. Okay, 10301 MPLS IPsec. So this is the private IP. Let me just copy paste and I will compare it for you. Okay, let me just, right, visible, it's visible. Now okay, this is one of the, now let's go to the other one. Let's go back to, hey man, walk, vSmart. Now let's check the other one. So this is the public internet one, right? copy paste, right? Look here. So this is the second T-lock that we have, right? Now, what is the preference? Lowest T-lock private address, guys. This is which T-lock? MPLS. This is which T-lock? Public Internet. So these are two colors representing their own T-locks, right? What is the private IP here? 172. What is the private IP here? 192. Which one is lowest? Yes. Which private IP is lowest? This one. So that's why this path is preferred. Clear? That's why this path is preferred. So I hope you are clear with the path preference criteria in OMP, right? So it is not that much complex like BGP, right? And if I have to tell you what things we are using in real time, we are using route preference or T-lock preference, right? Route preference or T-lock preference for what purpose? For route manipulation, right? And otherwise, if there is no manipulation, the tiebreaker will be formed on the basis of the lowest T-lock IP address. Will be formed on the basis of lowest T-lock IP address. Clear? So this is not even difficult to understand. So now let me go back to your vSmart. I am already here. I will go back to VPN 0. Sorry, I will go back to OMP and I will change this command to the default value. Default value was 4. Commit, right? Show run. So when I see it now, so there is no command seen here. It means it is on its default value. Clear, guys? Now if I go back to VH4, we are receiving prefixes from both the T-locks, right? MPLS also and public internet also. Guys, if you have a doubt, feel free to ask, right? Now, the next question is, what are the different sort of origins and what is there and which origin has priority over the other origin? So guys, we have different origins available, right? So these are the different origins we have, right? First one is connected, second is static, right? Third one is EBGP, then you have OSPF, then EIGRP, then IBGP, and last is unknown. Unknown means the routes which are redistributed. Right? Any problem in understanding this part? Please feel free to ask. Right, so there is one more command to check this thing. Show OMP route. Let's say you want to check it for this of the network, right? Detail. Okay, let me change it in a tabular form. Sometimes it starts playing with me. Okay, let me just So this particular prefix is available from two particular, what I say, two particular T-locks. I want to show it to you in a tabular form. Let me just make it big. Let it work now. No, it is not working. Actually, this is happening because of the big font size. Okay, let me just try to copy it. Sometime it works fine with a notepad. Like it is working now, it is working fine. Yes, you can see. So this is my prefix. From these peers I am receiving, right? So the prefixes are installed. These are the T-lock IPs, right? So we are not doing any manipulation, right? So no preference is set, no tag is set, right? So it is just showing multiple times. The attributes are same. No difference is there. Fine. And I think, okay, you can see the protocol here also, the static, how they were advertised in OMP, right? Fine. So this is more on the topic, right? So there's one more command I want to show you. Just a minute. Show OMP services. Let me just check it. Okay, so let me just try to show you VH4, not for this one. So many times you will see these flags while working with your SDWANs. Fine. So C means chosen, right? R means redistributed, and second R means resolved, right? So a resolved means the next hop is reachable or not, right? We are able to resolve the next hop or not, right? Red means yes, these OMP routes are redistributed, right? And C means we are choosing these routes. Fine. So there is a concept of path ID and label also, but that is again a higher level concept. So you don't need to dig into those things right now. Maybe in future we will see them, but not in this course, right? So that will be, that you can call advanced level SD-WAN, where we can talk about this path ID or this stuff, labels, things like this, right? So let me discuss one more feature with you that is related to OMP graceful restart. Right. So guys, let's have a 2 or 3 minutes break. I want to use the washroom. So I will connect in 2 minutes. So guys, there is one feature that is called OMP graceful restart. What do you mean by this feature? So again, it is very easy to understand. It's not a rocket science, right? So I have now, first of all, I have not tested this feature in the lab environment, but I'm happy to make you aware about it. I will test it right now. So we know that our V edges form a OMP peer ring with whom? With vSmart, right? Right. And after receiving the OMP peering from after receiving OMP peering information from the vSmart, we just start communicating with each other, right? Now what will happen if the controller suddenly restarts or it goes down, right? Your control planes will be down. How control planes will be down? I told you there will be a DTLS connection between your VH and your vSmart over which OMP runs, right? So if your control plane is down, routing information will be lost, but it will not happen. So thanks to the OMP graceful restart feature. So let me just show you on vSmart itself. So there is a graceful restart feature available. So what is this feature? If in any case vSmart goes down, both of the V edges will be communicating with each other. Guys, again I'm telling you, I have not tested this feature in the lab environment, but yes, if you have the actual devices, right, this feature will work and your V edges will keep on forwarding traffic if they are even not able to communicate with vSmart, right, for some time, right? So this is called the graceful restart feature. Fine. So I think you are clear with the feature. So the feature is very simple. I am repeating it again. So by default, all your V edges will have a control connection with whom? With vSmart, right? It means all the routing information is received from whom? From vSmart, right? What will happen if vSmart goes down? Goes down, right? So if we have this graceful restart feature, right, enabled, V edges will be communicating with other V edges on the basis of last learned information, right? On the basis of last learned information. I'm not saying they will not try to re-establish communication with vSmart. Yes, they will be trying to re-establish the communication with vSmart, right? And they will wait for vSmart to come up. So you can set up a graceful timer also, but by default there is no timer set. So if your vSmart goes down, VH will keep on communicating with each other, right? So guys, this is the beauty of segregating control plane from data plane. So my control plane is down, but still V edges are continuing forwarding traffic using their cached OMP information. Cached means saved, right? So if you're not clear with any word, you can ask me. Cached means saved OMP information, right? So if I have to go to the lab, if I have to go to vSmart, right, and if I have to show you show run OMP, so graceful restart feature is enabled. So what I will be doing is, right, so to check this feature, if this feature works in a lab environment or not, I will generate a ping from here for 15.15.15.15 with a repeat count of this much. Okay, why it is not communicating? It is communicating now, right? And side by side I will reload my vSmart. Okay, system, just a minute. What was the command? Yes. Fine. Again, I'm saying I have not tested it in the lab environment. I'm testing it for the first time. We can go to VH4 also side by side to check the status of show OMP peers. Okay, vSmart is still up. So I think vSmart is going down. I should have reloaded it from there. Okay, you can see vSmart neighborship is down. Init in graceful restart. Clear? So this is working in a lab environment also. That's very good for us, right? So init in GR means this particular device is trying to communicate with vSmart, and here you can see the color of vSmart. vSmart is power off. But we are still able to communicate over the fabric. Guys, this is the beauty of segregating control plane from data plane. By default, there is no timer set, and I have not seen any command also for this timer, right? If I will set this timer, let's to 2 minutes, and in 2 minutes my vSmart is not up, my data plane will be interrupted, right? So that's why I don't think Cisco has any command for it. Fine, I have not seen it myself, right? You can see these are communicating, but the neighborship is in this state, graceful restart state. Sorry guys. See, this is the state. You can read about the state also. Now let me do a real thing real quick. Let me start my vSmart, right? So sometimes people ask me that, Piyush, what is the benefit of separating control plane and data plane? We don't see any benefit from a data plane perspective. You can see this is the benefit, right? So there are multiple benefits, but this is just one of them. Fine. So data plane is continue to flow without a single drop. Even your control plane was down, right? Go to VH4. You are not trusting me? Okay, no problem. Shall I start a ping from R15? Right? I'm not able to stop it. That's why I just run it from the other end. Right? No, there is nothing related to IPsec tunnel. And just for your information, let me tell you, there is no IK tunnel built in, right? Right? There is no control plane for that tunnel, right? We just have the keys. We are encapsulating it and sending it over the tunnel. And let me tell you one more thing. Now we have two tunnels, one over public transport, other over the MPLS transport. Let me try to stop it. But anyway, my OMP peering is up now. State is up, right? We are good from that perspective. So I'm not able to stop it. I think I have a very large amount of packet count here. Okay, let me try to stop it. Okay, I've tried it many times, but it is not working for me. Fine. So what you can do is when you are doing practical in your lab, so first of all you can send like 100 packets. You can bring down vSmart, right? And after that, once 100 packets are done, you can try to reinitiate the ping. But the concept I tell you will remain the same. There will be no difference, right? But to be honest, I have never seen people in real-time scenarios manipulating these things. They keep it as they are, right? So my vSmart is up now. Admin. Now just go here. Just go to the dashboard. Right? On vManage. So your vSmart is up, right? Now guys, see here. How many WAN edges are there? 2 WAN edges are there. There is full WAN connectivity, right? What do you mean by full WAN connectivity? that both vans are connected by both the transports which are available. Both vans are connected by both the transports which are available, right? So now go to monitor. Never open a device from here. It's not a good practice. Always go to monitor, go to network, select a device. Let's say you want to open vSmart, right? So these are the control connections for the vSmart. I want to see it from a device level itself. System status. Okay, can you see here? A reboot count has increased. And why the device was rebooted? It was initiated by the user, right? Let me go back. So things like this also we can check. So in my lab, the physical thing, modules, temperatures, USB, power supply, fans will not be applicable. But still you can see we are utilizing 16% of the memory and a very less amount of CPU. It's negligible, right? Again, I will go to network and I can select any other device for which I want to check, right? Like you check for VH3 if you want to check anything. So how much CPU, how much memory. So I've already walked you through these things. Okay, here I am expecting. Okay, you can see the logs. These are the alarms. So let me open them from here. I'm just clicking here on cross. I'm clicking here on alarms, right? So these are all alarms. So in SD-WAN deployment, alarms are categorized in 4 categories: critical, major, medium, and minor, right? So if your BFD or things like this goes down, so there will be a critical alarm, like you can see here, right? You can see in the graph, right? So critical and major alarms were generated when your T-lock, your BFD things will go down, right? I think here you can see your vSmart also came up. It went down before some time. A device was rebooted, so vSmart was rebooted, so the critical alarm was generated. So what you can do is either you can check the alarms here itself, or you can send it to a separate monitoring server. So we have different type of monitoring servers in real-time scenarios. So one of those kind is SolarWinds. We have Interlinks, we have NNMIs. So there are multiple types of PRTG. So there are different types of monitoring tools we have in real time, right? So you can do the monitoring from here also and from real time also, no problem. So if you have any problem with this feature, let me know. Otherwise, what I will be doing right now is I will be going to my lab, and first of all I will be turning on the interfaces connected to VH5, VH1, VH2, and I will be bringing up VH5 first of all. Okay, let's do it step by step. First of all, go to the MPLS device, router BGP 100, right? So BGP default IPv4 unicast, guys. I cannot define the neighborship and activate it, right? So I cannot waste that much time here. So that's why I'm running the command that form the neighborship by default for IPv4 unicast address family. There is no separate requirement of activating it. Neighbor. So before defining neighbor, let's define the interface E1 by 3. No shut IP address 172.31.15.1, right? After that, router BGP 100, neighbor, right? Neighbor IP will be 15.2 if I'm not wrong. Clear, guys? Remote AS will be 65005, right? Now guys, what is the good thing about this site? And the good thing is this site only has a MPLS connectivity. It does not have a internet sorry, internet connectivity, right? So what we need to do is we need to build a configuration for this particular VH. So right, so how we are doing it? So let's revise the things. Bringing up V edge 5, right? Bringing up VH5. So guys, first thing will be your system configuration, right? First thing will be your system configuration. After that, there will be VPN 0 configuration. First will be system. After that, VPN 0, right? After VPN 0, there will be BGP configuration, right? So you will ask, Piyush, why you are not downloading the certificate thing first? Because we did the same on VH3 and VH4. Guys, remember, those sites were having internet connectivity also, right? This site only has the MPLS connectivity. So before going to communicate with any of the controller segment, we need to build the BGP, right? So we will build the BGP. Okay, after building the BGP, I don't want to miss this command this time, right? Last time also I forget this and we went into a problem. And the last thing that I'm going to do is, let me copy paste the commands. Okay, these commands I will be using to boot the device onto the fabric. Right, so let's just make it according to VH5. So host name is same, VH5, system IP 10501, site ID 5, organization name Viptela SDWAN, vBond address is correct, right? So just bring it down. So interface is the 0x1, no shut, IP address will be 15.2. Tunnel interface, encapsulation IPsec, color MPLS, allow service all. After that, VPN 0 once again. Router, BGP, network will be 15.0 and neighbor IP will be 15.1. Right guys? So let me just copy paste this particular commands here on the VH5. VH5. Okay, let me just turn off. Okay, we manage. I will be needing. I forget. R13, R14. Let's just close them just to clean it up. Okay, we require. Okay, let's keep them. Control Z. Fine. Copy once again. Go to VH5. Go to conf t. It is done. Exit. Commit. So once you commit the configuration, we are expecting. Yes, please. Please, what you're saying? Okay, you are right. Router BGP should be 65005. So let me just change it. Very good. So let me just copy it again. I have corrected it. Exit, commit. What it is saying? Okay, let me see what is the problem. Do show run VPN 0 router BGP. It will ask me to remove first of all this one. Okay, no, now I can configure it. Right. So as we know, on a iOS router also we cannot run two BGP processes simultaneously. So the same thing is true for the VH also. You cannot run two BGP processes. So as you know, the AS number was wrong. That's why I was getting this error, wrong AS number. Now everything is good. So we are good from this perspective. Okay, that is fine. We are getting. No, we have not advertised 15.0. We have advertised. Sure, why I am not receiving it? I should receive it. Show run pipe section BGP. Just a minute. Show IP BGP summary. Okay, I am receiving now. Yes, we are receiving 15.0. We are good. Let me write the configuration here once again. Right now, my BGP is up. It means this VH is now able to reach the controllers, right? So if you try to ping, we are able to ping. You can ping any of the controllers like your vBond and your CA server, right? We are good. Now let's start booting this device to the fabric. So first of all, we will uninstall the certificate, right? After that, we will download the certificate from the CA server. It's done. After that, we will install that certificate, root certificate, right? Installed. After that, we will generate a CSR. CSR is generated. Now we will go to vshell. Guys, please don't copy paste this configuration when you are doing the practical for the first time. Try to run each and every command to understand more about the meaning of the command. ls to check how many files are there. So we have csr.txt. Now open this file, mol.csr.txt. Copy paste the certificate, right? Go to your CA server, get it signed. Crypto PKI server, PKI request PKCS10 terminal. Paste, enter. You will get a granted certificate. Here you can see. So I will copy paste this certificate. Go back to my VH5, right? Now I will create a file, right? With what command? Cat means create, close. What name I will give it? cert.txt. Right click, enter. File is created, check it. So this is your CSR and this is your identity certificate. Now let's install it. Exit, request, certificate, install, home admin cert.txt. We have the certificate. Now show certificate serial, right? So what we are going to do now, we are going to add this device manually to whom? To vmanage and vbond, right? So in the meantime, let me turn off CA. vsmart we don't require, MPLS we don't require, DC switch we don't require. Okay, this thing is fine. Show certificate serial, right? Let's go to vmanage. Here, just bring up VH5 also, right? Right, now you can type here request VH add chassis number and a serial number, right? and we have to copy paste the same command on vbond also. Let's go to vbond, admin, done. Now what I will do, I will go to vmanage, configuration, certificates, manage list, send to the controllers, right? I want to send the list vmanage has to the controllers. To which controllers? Here I am only worrying about vsmart, because to vmanage and vbond it is manually defined. So vsmart still does not know about it, right? So I'm pushing it down to vsmart also, so that my all control connections will come up. Show control connections. So I have a connection with vbond and vmanage. You can see we are good from that perspective. So I'm hoping once the configuration is pushed, yes, now VH5 will form a control connection with vsmart also. So let's wait for some time. Show OMP peers. So let's wait for some time. Okay. Sometimes it took more than the expected time, but it is on vsmart now. Okay, let me just for the sake, we will not run into any problem. Let me just send the list again to the controllers. Now let me just cross check. So if this happens to you also, you can also just send the list again to the controllers, no problem. Now see, it is bringing up a DTLS session first of all with the with the vsmart. Now check the OMP peering. The state is up, right? But we are not receiving any routes. Why we are not receiving any routes? Anybody want to answer? Anyone, guys? Anyone want to answer this particular thing? Why? Why this? Very good, because there is no service VPN advertised on VH5. So let's advertise it. So how we will be doing it? VPN1 interface G0/2, right? IP address 10.5.14.5 10.5.14.5/24, no shutdown. Commit. Show IP route VPN1. Are we receiving 13 and 15 networks via OMP? Yes. Right? Next, show IP route VPN2. Why I am not receiving any routes for VPN2? Because VPN2 service VPN is still not enabled. Right? Now let's write here VPN2 interface G0/3, IP address 10.5.100.5/24, no shutdown. Commit. Now let's check show IP route VPN1. We have few networks. VPN2, we have few networks, right? Now again a question to all of you. How these VHs are going to communicate with each other by default? So they will be communicating in a full mesh topology. Full mesh means VH5 will directly reach to VH4, VH3 will directly reach to VH4, VH4 will directly reach to VH5 and VH3 respectively. Clear? Any problem in understanding this? Now VH3 is also part of the fabric, right? But the problem with VH3 is VH3 only have how many transports available? One, right? That is your MPLS transport. Clear guys? Any problem? Feel free to ask. Right? Sorry. Now let me go to the MPLS device once again and let me configure the interfaces which are connected to VH1 and VH2. 0x1, no shut, IP address 172.31.11.1, right? One 172.31.12.1, right? After that, router BGP 100 neighbor, remote ACE. So here we will run 65012 because the site ID will be 12, right? Neighbor 65012, right? Right. Now let's bring up VH1 and VH2 onto the fabric, right? So guys, let's look here how we are going to do it. So before doing it, let me check that the internet router is correctly configured from an interface perspective. Show IP interface brief. Okay, we are very good. Right. We are good. So let's go to VH2 first of all. So guys, like I told you, I'm not going to do the whole configuration once again. I'm just going to copy paste the script, right? So in VPN 0, I want to add one more point because this particular site has both the transports, and under VPN 0, I also want to add a default route that is going to 220, okay, sorry, 192.1.1.1, right? Okay. So which device we are going to configure? VH2, admin, right? So what is the name? VH2, site ID, sorry, system IP 10.12.0.1, site ID 12, organization name Viptela SDWAN, vBond address is same. Okay. After that, what is the G0x1 address? It will be 172.31.12.2, right? Tunnel interface, encapsulation IPsec, color MPLS, that is good. Allow service all. Then again, which interface? Interface G0x0 192.1.1.2 because, sorry, 2.2 because this is your VH2, right? So 2.1 is the IP address here. So this command is not required. Okay, let me do this. Control C, let me replace this command with the no shutdown command, right? Tunnel interface, encapsulation IPsec, color public internet, very good. Let's remove it, not required. After that, let's remove VPN 0 once again. Router command BGP, what network I want to advertise? 31.12.0, right? 12.0 means the network that is connected to the MPLS device, right? 12.2, right? So neighbor IP will be 12.1, remote AS, next hop, IP root 192.0.0.0, 192.1.1.2.1, right guys? So this configuration is correct. So what I'm going to do right now is I will copy paste this configuration and I'm sending it to you over the chat also. You can save it on boarding of VH2, right? So I already have it here because I replace it with VH5 configuration. That's why I'm saying you can save it, right? Let me just copy paste this configuration up to this point and I think we are good. We are good. Okay. Conf t right. Now the last point is commit. I don't forget to commit, right? So I'm expecting show BGP neighbor. BGP is still idle. Okay, again the same problem we did. 65012, right? So I need to copy paste this configuration again. VPN 0, no router BGP 65005, right? Let me paste the correct configuration this time. Right, so guys, AS number is a problem. I'm making the mistake multiple times, so please take care when you're doing the same configuration. Right, so if I go back here now, check show BGP neighbors. So neighborship is established, show IP route, right? So we have connected and BGP routes. So now this guy is able to communicate with the controllers, everyone over the fabric, over the underlay network, right? Not over the fabric, right? So if you want to ping 223.1.1.1, it is able to ping. If you want to ping the vBond address, it is able to ping. And if you want to ping the CA server, it is able to ping. So 13 is the IP, right? Now let's do the other part of configuration. First of all, uninstall the certificate that is on the device itself. After that, download the root certificate from the CA server. Done. After that, install the root certificate. After that, generate a CSR. Done. After that, go to your vShell, take your CSR, take it to your CA server, right? I closed it, sorry. Crypto PKI server, PKI request, PKCS10 terminal. Enter. This is a granted certificate. Copy paste. Right. Go to your VH2 cat what will be the file name cert.txt, right? paste, enter, done. ls, we have the file, exit, request, certificate, install, home, admin, cert.txt. Done. Show certificate install, show certificate serial. This is the serial number. Go to your vmanage and vbond, vmanage, right? Request, vh, add, this is your chassis number, right? And this is your serial number. What is the serial number? 08. So where is your vmanage? Chassis number, serial number 08. Done. Copy paste the same command. Go to your vbond and paste, right? Next, go to the GUI configuration. First of all, go to devices. Fine, just refresh it. You can see 4 VHs are there. VH2 is also there. Now go to certificates. So 4th VH is there. Send to controller. So I think VH2 should be good without any problem. Show control connections. So 2 connections with vbond, 1 with vmanage, 1 over each transport. Now vsmart, with vsmart also there is a connection. But I'm expecting 2 connections to vsmart, right? Okay, check show IP route. Yeah, 2 connections to vsmart, 2 to vbond, 1 to vmanage. That's fine. Show IP route OMP. Show OMP peers. It should have OMP routes. So anyone want to tell why it does not have a OMP route? Again, the same reason, because no service side VPN is defined here. Clear, guys? Now let's onboard VH1 also. So I don't think so. You think that there is a long process that we have to follow. No, there is no long process. If you have the script prepared, you can do it in like 5 to 10 minutes maximum. That's what I'm saying, right? Now let's close VH2. Okay, we require these. Let's close these also. We don't want these for today now, right? Now VH1 will be the device. Okay, so remember this thing that on VH2 we by default define system IP 10.12.0.1. So I want to change it also. Go to VH2. Show run system. It should be 10.12.0.2, right? So system IP 10.12.0.2. Exit, commit. Now let's see, show run system IP is 10.12.0.2. Now go to vmanage if it is updated here or not. It is updated, you can see. So I can do the changes from CLI itself. Now one thing, if you can notice here, the mode of all the devices is CLI. CLI means we are managing all the devices from CLI, right? So tomorrow we will discuss about how we can manage them through vmanage, right? But first of all, let's bring on the VH1. Okay, where is the VH1? Here it is. Right, let's do it. Okay, name will be VH1, system IP is correct, site ID correct, vbond address, gig 0 by 1 interface, IP will be 11.2, right? And gig 0 by 0 interface IP will be 192.112. Router BGP is correct, network will be 11.0 and neighbor IP will be 11.1, right? Next hop will be 192.1.1.1. Any changes you want me to do here, right? So VH1 is good. Okay, I changed it already on VH2 10.12.02, right? So that's why I'm keeping it here. Now VH1 conf t, right click, exit, commit, show BGP neighbors. So BGP is idle, it is established, show IP route, right? 0000. BGP routes are also there. For the other sites you can see, and this is the controller subnet, so I will be able to ping. Very good. I will be able to ping the what I call my vbond and side by side the CA server, right? So let's uninstall the certificate. Now let's download the root certificate from the CA. Install the root certificate, generate a CSR, right? Okay. Right, CSR is generated. Now go to vshell, check the files, open mol.csr.txt, take your CSR, go to your CA server, crypto PKI server, PKI request PKCS10 terminal, enter. So this is your granted certificate, you can see here, right? Now I have to create one more file to copy this certificate onto this device, cert.txt, right? Done. So if you check ls, you will have a file cert.txt, right? Now just install the certificate. Do exit from here, install. It is installed, show certificate serial, right? Now this is your new serial number. Go to vmanage, request vh, add chassis number. This is the chassis number, serial number 09. Copy paste the same command where on vbond, right? Now go to your vmanage, configuration, network, devices, and just do a refresh. We can see VH1 here, right? VH1 is here. Now I will go to certificates, right? And I will push down the controller list to my vSmart. I'm pushing it to all the controllers, but the main motive here is to give information to vSmart because vBond already knows about it. Right, so once it is done, VH1 is also on my SD-WAN fabric, right? So it is done. Now let's go to VH1, right? Show OMPPS, right? So we are having a OMP neighborship built with the vSmart. Now guys, the last thing that we're gonna cover today is we are gonna enable the interface which is connected to switch 16. So switch 16 is not configured for anything right now. So I will just configure the interface on switch 16 which is connected to which VH1 and VH2, right? So this is basically a router. I am using it as a switch 16, right? So one interface is E0 by 0, no shutdown, no switch port. So if you don't know any of these commands, just copy paste them. IP address 10.1.16.16, right? Right? This thing is clear. Next. Interface E0 by 1, no shut, no switch port, IP address 10.2.16.16. Right, do right. Fine. Now let me configure the interfaces on VH1 and 2 which are connected to switch 16. Right. How I will do it? I'm on VH1. I will go to VPN1, right? Interface GE0 by 2. No shutdown. IP address 10.1.16.1. Sorry. Right? And at the end I will commit the configuration, right? Next I will go to VH2. Again I will write here VPN1, sorry, interface GE0 by 2, IP address 10.2.16.2, right? So 16.2 will be easy to remember, right? Because 1 on VH1 and 2 on VH2 because of the VH numbers, right? No shut. Comment, right? So you can see I have configured service side VPN number 1 on VH1 and VH2. So show IP route VPN1. So I am receiving the prefixes. You can see if you see any of the prefix, let's say 13 prefix. Via how many transport? 2. So guys, I already told you the meaning of the status. So F means this route is in the forwarding information base. S means this route is selected, right? So you can see all the networks are there, right? Via OMP. All other sites, VH3s. Okay, let's take it site ID 3, site ID 4 and site ID 5. All the routes are there from these sites, right? Now, the last concept that you have to remember for the day is when I am checking the routing table on VH1, so just think of it like this. Okay, let me just take a snap and take it to my paint. Right, so here I have the snap, go to my paint, just scroll down, Control V, just bring it here. Now look here. So we have VH1, this is VH2. These are the LAN networks which are enabled, right? Part of VPN1. Now The point is VH1 should be advertising this LAN network to the vSmart, right? And vSmart will be advertising it back to VH2 also, because both have the OMP peering, right? But on VH2 you will not see this LAN network 10.1.16.0. Similarly, on VH2 you will not see this LAN network 10.1.16.0. Why? Let me show you first of all. Come to VH1. So you will not see here 10.2.16.0. You are not seeing, which is connected to VH2, right? And here if you come to VH2, show IP route, you will not see 10.2.16.0. Okay, let me just make it more clear by running a specific command vpn1, right? So here you cannot see 10.1.16.0, right? The reason is, in case of OMP, we have a loop prevention mechanism. What is that? Whenever any particular device advertise its connected server-side VPN routes, with those routes it will add the site ID, right? So site ID 12 is advertised from VH1 to vSmart. vSmart will advertise the same site ID to VH2. Now VH2 will see that my site ID is 12 and I am receiving this particular route with site ID 12. I will discard this route, right? So this is very similar to BGP AS path loop prevention mechanism. Clear, guys? Any problem in understanding this? Clear? So what I am trying to say that VH1 will never send traffic to reach this particular network over the WAN, right? So if it will start learning, it can send, right? In case this link goes down or something bad happens. So it can send the traffic to its own intranet over the WAN. So we don't want this to happen, right? So that's why we have this particular rule in place. So if you have any doubt in this, you can ask. Feel free to ask. So in the meantime, what I'm going to do is I'm going to take this file first of all. Guys, if you have any doubt, feel free to ask, please. So guys, I have shared the config file and the class file over the WhatsApp group. Maybe you will receive it in a minute. Apart from that, guys, what about next week? So next week will be New Year. You guys will be available?